Building intelligent agents is one of the most exciting shifts in software development right now. But moving from a basic chatbot to a production-ready enterprise-grade workflow is notoriously difficult. Today, we are diving into Astron Agent. This is an open-source Apache 2.0 licensed platform designed specifically to bridge that gap between cool demo and robust business automation. What makes Astron different from your average agent framework is its focus on high availability and its native integration with RPA. It doesn't just think, it acts across legacy systems and modern APIs alike. First, let's get this running on your local machine. Unlike cloud-only tools, you own this infrastructure. We are following the Docker Compose guide from the GitHub repo. Step 1. Clone the repository. Step 2. Navigate into the Docker directory. Step 3. We need to set up our environment variables. Open the .env file. This is where you configure your database connections and model API keys. For this demo, the defaults work great, but make sure to add your LLM provider key here. Now, fire it up. Once the containers are healthy, head to localhost. Default login is usually admin/123. Now, let's get hands-on and build one from scratch. Navigate to the dashboard and click the Create Agent button. A modal will appear. From here, we are going to select Create Workflow. This opens up our orchestration canvas, where we can begin defining the logic and sequence for our agentic process. The core of Astron is the Workflow Orchestrator. Instead of writing massive blocks of brittle Python code to handle agent handoffs, you use a low-code canvas to design the logic. Let's build a research and content automation workflow. In this scenario, we'll drag in a start node that takes a topic as input. From there, we connect it to a research agent. Within Astron, you can equip this agent with specific tools, like web search or document parsers, from the built-in tool ecosystem. Next, we'll rename our node to keep things organized. From there, select your preferred model type and specify the input. We're going to map this directly to the user input captured by the start node. Now, we'll define the system prompt to set the agent's behavior and the user prompt for the specific task. Finally, we'll configure the output format to an array, ensuring the data is structured and ready for the next step in our workflow. Next, we create a conditional logic branch. If the research finds sufficient data, the workflow moves to a content synthesis agent. Now, let's add another node to the sequence. We'll follow a similar process to our research node. First, we'll rename this one the content synthesis agent. Next, we'll select our model, map the input from the previous step, and define our system and user prompts. If it doesn't, it loops back for a deeper search. To handle the deeper search, we'll create an iteration node. This node will take the reference input directly from our decision node and will set the output type to an array of strings. Now, let's expand the child node view. We're going to insert a model node between the start and finish markers, applying the exact same model settings we used in our initial research nodes to maintain consistency throughout the loop. This kind of looping and self-correction is where Astron excels compared to linear automation. Now, we'll link the iteration node to the content synthesis agent and then connect the entire sequence to the finish node. Before we can go live, we need to debug the workflow. It looks like we have three major errors to resolve. First, we'll address the decision node error. It has an uncommitted edge for the default intent. So we'll link that path directly to the iteration node to ensure the logic has a fallback. Next, inside the iteration node, the output node has an unsatisfied requirement. We'll go in, correct the output mapping, and then reset the workflow. Now that our canvas is clean and error-free, let's add a prompt to test it out. We'll give the system a moment to process the multi-agent logic. You can actually see each step coming to life as the workflow executes. And once every node turns green, you know the process is complete and the output is ready. And voila, it works. This is amazing. Now let's publish this workflow so everyone can use it. We'll start by hitting the publish button. First, we'll create the initial release and then move into configuration. To turn this into a functional application, we'll generate a unique API name and add a clear description. If you're looking to scale, Astron supports one-click deployment for mass model as a service on-premises clusters. This ensures your data stays within your infrastructure while still getting the power of large-scale LLMs. I've exported the workflow JSON for this agent and uploaded it to GitHub. You can find the link in the description. I'm also contributing this to the awesome Astron Workflow collection. This is a community repo where developers are sharing their best agent architectures. Here is my challenge to you. Clone the Astron Agent repo, run the Docker Compose command, and build a workflow that solves a problem you have. Then submit a pull request to the awesome list. If you are an enterprise developer or just love open source AI, this is a tool you need to watch. Links are below. Thanks for watching and happy building.